Hello, everyone. Today, Michelle and I will be giving a deep dive on Kubernetes SIG Storage. Here are the SIG Storage leads. My name is Xing. I work for VMware in the cloud storage team. I'm a co-chair of SIG Storage along with Sada Lee from Google.
And my name is Michelle Oh. I am an engineer at Google working on Kubernetes storage. I am one of the tech leads along with Jan from Red Hat.
Here is today's agenda. First, we will talk about what is SIG Storage. We will talk about what we have done in the 1.18 release and what is coming in the 1.19 release. And we will talk about our future plans, what we will be working on after 1.19, and how to get involved with the SIG storage. So what is SIG storage? SIG storage is a special interest group that focuses on how to provide storage to pods in your Kubernetes cluster. SIG storage's scope is in the storage control plane. It provides a way for containers in the pods to consume block or file storage. This can be persistent long-term storage that lives beyond a pod's lifecycle, or it can be ephemeral temporary storage, which becomes available when the pod is started and goes away when the pod goes down. SIG storage is responsible for the lifecycle of volumes used by the pods. This includes provisioning a new volume, attaching a volume to the node, and mounting it so that the pod can use it, unmounting, detaching, and deleting the volume when it is no longer needed, taking snapshots so that it can be used to restore the volume if the original volume is corrupted for some reason. SIG storage also looks at how to influence the scheduling decisions based on topology information to see whether the storage is accessible to a node and make sure volume is scheduled to a node which can have access to the storage. Also, SIG storage is responsible for managing storage capacities, managing quota resources based on capacities or number of resources, and provides ability to expand volume if volume runs out of space. SIG storage owns the persistent volume and persistent volume claim feature. This allows storage vendor to create a volume and persist data in this volume, which can be preserved even if the pod goes away. We have the storage class concept. A storage class provides a way for administrators to describe the classes of storage they offer. Different storage classes might map to different quality of service levels of the storage system. In dynamic provisioning, storage class is used to find out which provisioner should be used and what parameters should be passed to the provisioner when creating the volume. Kubernetes volume plugins include in-tree plugins, auto-tree flex volume, and CSI drivers. The Kubernetes implementation of the Container Storage Interface CSI has been GA since the Kubernetes 1.13 release. SIG Storage has been working on migrating from in-tree plugins to out-of-tree CSI drivers. New features are only added to the CSI drivers. CSI is supported by multiple container orchestration systems and storage vendors. It is designed to be vendor neutral, interoperable, and has a focus on specification. It defines a set of storage interfaces so that a storage vendor can write one plugin and have it work across a range of container orchestration systems. Other than persistent volumes, there are also ephemeral volumes. Ephemeral volumes are specified directly in a pod spec. It's mounted on the pod as a directory. Data can be stored in a file under that directory. Ephemeral volumes include secrets, config maps, CSI ephemeral volumes, and so on. Its lifecycle follows the lifecycle of a pod. On this slide, you can also see a SIG Storage team page. Visit this page, you will find a lot of information about the SIG.
All right, so now we're going to move on and talk about all the new features that SIG Storage has been working on in 1.18. So we landed a lot of features and graduated them to GA status. First is the raw block feature. This allows containers to access a volume as a block device instead of as the formatted file system. This is very useful for workloads such as high performance databases that may operate and have optimizations with their own file system format and want to deal with a block device instead of actually having someone else format the file system on it. So that feature is now GA for both in-tree and CSI drivers. The next feature that is GA is cloning. This is a feature that is only available to CSI drivers, and this gives the ability to create a PVC as a copy of another PVC. The next two features are also CSI specific. One is called the skip attach feature. This allows a CSI driver to indicate that they don't support the attach operation and they don't have to bundle the CSI attacher sidecar with their driver. So that's what this feature enables. And then the next feature, CSI pod info on mount. This allows a CSI driver to receive pod information such as the name and namespace of the pod that is mounting this volume. And this is useful if the CSI driver needs things like pod-specific credentials or any other pod-specific info. So those are the features that graduated to GA. Next, graduating to beta is OpenStack CSI migration. So overall, the CSI migration feature allows users to continue using the Kubernetes in-tree volume APIs. But the main difference is that the back end of Kubernetes will call out to the CSI driver instead of calling out to the in-tree volume code. So the main purpose of this feature is so that we can remove as many third-party dependencies from the core of Kubernetes as possible. This will bring a lot of security benefits and also help reduce the vendor size of the Kubernetes components themselves. So the OpenStack implementation of this has gone to beta in 1.18. And then in 1.18, we also introduced a number of new features that are alpha. First is CSI Windows. This is basically the ability to support CSI drivers on Windows nodes. So this is now in alpha, and currently there are a couple of CSI drivers from Azure and GCE that support this, and I believe more are coming on the line. For all of these CSI features, they all depend on the CSI driver to actually support and implement it. So please check with your CSI driver whether or not it supports these features. The next alpha feature is to be able to support setting an FS group change policy in the pod security context. So this is to help solve a scaling problem with the current FS group implementation, where Kubernetes has to recursively walk through every file in a volume and change the ownership of those files to match the ownership on the pods. This is very time consuming for volumes that have a lot of files in them. So this alpha feature is providing an option to optimize that so that we don't have to actually recursively walk a volume on every single mount. Instead, what this new change policy offers is the ability to only update the ownership of a volume on the first mount when it detects that the ownership of the volume is different from the pod. So that is a great alpha feature out that will help, that can potentially help reduce the mount time for any of your volumes that have a lot of files in them. The last alpha feature is also a scalability feature. This is the ability to mark a secret or config map volume as immutable. And this feature will basically help reduce load on the API server from nodes, because currently kubelet needs to watch the secret and config maps for updates and then be able to update the volumes periodically. So if you run a lot of pods on nodes and you have a lot, and those pods are using a lot of secrets and config maps, you may hit some API server bottlenecks with that. So this feature is going to help for those use cases. So those are all the features that we've done in 1.18. And now I will go through all the features that are planned to come in this upcoming 1.19 release. So we are currently in the middle of, or we're close to the end of the release cycle for 1.19. The 1.19 release is targeted to be in a little over a month now, on August 25th. So I'll go through all the features that SIG Storage is planning for the 1.19 release. So graduating to beta are the Azure Disk and vSphere CSI migration features. So these are just additional cloud provider implementations for the overall CSI migration feature, and will allow the core Kubernetes APIs to be supported by CSI backends. And so this release adds the Azure Disk and vSphere implementations for that. And then similarly, the CSI Windows feature that we introduced in alpha in 1.18 is graduating to beta in 1.19. And also the immutable secrets and config maps feature that was introduced in 1.18 is now graduating to beta in 1.19 as well. In addition to those graduating features, we are continuing making improvements on existing beta features. So these features have graduated to beta in earlier releases. They are remaining beta in 1.19, but we are making continuous improvements to them. So first up is volume expansion. There are improvements being made related to the way that we process offline expansion for volumes that can only support doing a volume resizing operation if the volume is unmounted. So detecting that support in the driver and then having Kubernetes orchestrate the volume expansion operation to work with those kinds of drivers is a big improvement that we are making in 119. And then the volume snapshot beta feature, which was introduced in Kubernetes 117, we are continuing to make bug fixes and other improvements to the implementation. 119 also comes with a number of new alpha features. First up is CSI storage capacity tracking. So this feature gives a way for a CSI driver to report how much capacity they have for a storage pool on a particular topology. So if you have a local volume CSI driver, this feature lets you node per storage class. If you have a CSI driver that deals with storage on a rack basis, you can report how much capacity you have for provisioning volumes on a per rack and per storage class basis. So this is a really important feature that will help enable local volume dynamic provisioning, which has been a pretty long awaited and requested feature. So this is one of the key features we need to enable that use case. So if you are interested in this use case, please go ahead and try this out with your CSI driver and help us fix any bugs and make improvements to it. The next new alpha feature is generic ephemeral volumes. So this is sort of a improvement. It's sort of an additional alternative method for implementing ephemeral volumes in CSI, although it's not actually specific to CSI. What this feature lets you do is it lets you take any volume plugin today that supports persistent volumes. It allows you to specify them directly in a pod spec and have the volume lifecycle handled automatically. So what that basically means is when you specify in a generic ephemeral volume in your pod spec, you will actually specify a volume claim template, which is very similar to the PVC spec, and underneath the covers, it will go and manage the life cycle of that PVC with the life cycle of the pod. So this feature is really powerful and can enable a lot of use cases, such as having a external any CSI driver automatically gets supported with like a scratch space use case. So if, for example, you want to use an EBS volume as a sort of an empty dir type of volume where you're just using it as scratch space and you want it to get deleted when you delete the pod, you can use this feature to specify an EBS, a PVC using a EBS storage class. And the provisioning and deletion of the PVC will happen automatically by and will be managed by Kubernetes. Another important use case that this can enable is something like offering a empty dir alternative, but using specialized local storage. So if you have, say, a CSI driver that can provide local storage with using local SSDs on your node, you can use this feature to basically provide an empty dir-like behavior or empty dir-like volume, but on top of a local SSD instead of using the boot disk on the node. So this is a very powerful feature. Again, I would highly encourage everyone to try it out and help give us feedback and help develop the feature further so that we can graduate these to beta and then GA. The next alpha feature that we have added is CSI volume health. This basically provides a way for CSI drivers to monitor the status of provision volumes and to be able to report that back to Kubernetes. Right now, volume health status is reported as events on the PBC objects, so that you have any monitoring. You can build some monitoring on PBC events to determine if your volume is in a healthy state or not. And then the last new alpha feature that we added in 1.19 is to add a FS group support policy on the CSI driver itself. This will allow a CSI driver to explicitly state whether or not they support FS group. So currently in Kubernetes, we use some heuristics to determine if a CSI driver, if FS group should be applied to a volume. And right now, the heuristic is that if it's a read-write once volume and there is a FS type set on the volume specification, then Kubernetes will go and apply the FS group changes to that volume. But what this feature does is make that choice actually more explicit by the driver, and the driver will indicate whether or not it supports it. And this will be useful so that drivers that fall outside those heuristics, like NFS drivers or any other multi-writer drivers, they can potentially opt in to having Kubernetes manage the permissions on their volumes.
Thanks, Michelle. I will be talking about our future plans, what we will be working on after the 1.19 release. There are a number of features that we are targeting GA or beta in 1.20. The first one is CSI volume expansion. We have been working on bug fixing in order to bring this feature to GA. We are planning to deprecate the online-offline volume expansion plugin capability in a future CSI spec release, targeting 1.4 CSI spec release. Online-offline volume expansion will still be supported. When a CSI driver receives a request for volume expansion, it should return failed precondition if it only supports offline volume expansion. But the request was issued while the volume is in use. Kubernetes will stop calling the CSI driver when it receives this return code. The next feature is a CSI volume snapshot. We have been doing bug fixing and adding tests, trying to bring it to GA in 1.20 release. We are going to add a validation webhook to enforce the API. For example, there can be only one source in the volume snapshot. It can either be the persistent volume claim name for dynamically provisioned snapshots, or the volume snapshot content name for pre-provisioned snapshots, but not both. Also, we want to make sure that these fields are immutable. Similarly, in the volume snapshot content source, it can either be volume handle for dynamically provisioned snapshots or snapshot handle for pre-provisioned snapshots. We are also planning to add metrics to the snapshot controller using the metrics utility functions that we added earlier in 1.19 release. The next feature is non-recursive FS group. This feature was introduced as an alpha feature in 1.18. It allows volume ownership and permission change to be skipped during the month. We are planning to bring it to beta in 1.20. And also, we are planning to bring the Azure file CSI migration feature to beta in 1.20 release. We also have some features that we are going to introduce an alpha feature in 1.20 release. The first one is passport service account token to CSI. This feature proposes a way to obtain service account token for pods that the CSI drivers are mounting volumes for. And the second feature is recovery from volume expansion failure. This allows recovery from volume expansion failure caused by insufficient quota. It relaxes the API validation and allows the user to request a smaller size than the previous request so that volume expansion can be completed successfully within the supported quota limit. However, this does not really support volume shrinking. The requested volume size must still be smaller than the original volume size. So we are also trying to bring this one to alpha in 1.20. And the third feature we're trying to bring as an alpha feature in 1.20 is non-recursive secure Linux. This proposes a way to speed up container startup by mounting volumes with the correct secure Linux label instead of changing each file and volumes recursively. We're also planning to add a configuration so that CSI drivers can opt in to support this feature. There are also a few features that have been in design or been prototyped. The first one is a SAF CSI migration that is being designed. The second one is volume groups. This feature proposes to introduce a new volume group CRD that groups multiple volumes together, and a new group snapshot CRD that supports taking a snapshot of all volumes in the same group to ensure right order consistency. We are also looking at how to use the volume group concept to support failure domain spreading. For example, how to place volumes in the same group across different disks in the same storage system. The next feature that we're working on is the generic data populator. This allows a PVC to be provisioned from an external data source, not just a volume snapshot or an existing PVC, but it could be an object store, a GitHub repo, or an image, or something else. There is already an any volume data source feature gate, which was introduced as an alpha feature gate in 1.18 release. We want to have a generic data populate implementation completed so that we can promote this feature to beta in the 1.20 release. The next feature is the container object storage interface, COSI. This feature allows an object bucket to be provisioned and used by a pod. There have been weekly design meetings. It now becomes a sub-project under SIG Storage. We have repos created under Kubernetes SIG for prototyping purpose. If you are interested, you can join the design meetings and help with the prototyping. We also have a cross-SIG working group called the Data Protection Working Group. This is a collaboration between SIG Storage and SIG Apps. I co-lead this working group with Xiang Chen from Google. In this working group, we have been discussing a number of features that we already talked about earlier, such as volume group and the generic data populator and so on. One feature the data protection working group has been working on is how to quiesce an application before taking a snapshot and unquiesce afterwards. We initially proposed an execution hook CRD approach, which requires an external controller to run command through the pod exec sub-resource. But during the implementation, we got feedback from the API reviewers that this is not secure. So now we are looking at another approach called container notifier, which is to define the command or signal as an inline pod definition. An external controller can request this container notifier, but kubelet will be the one executing the command or sending the signal to the container. This is currently still under design discussion. We also co-own volume expansion for stateful sets with SIG apps. Currently, we can only support expanding a volume used by a pod, but not with the stateful set. So this is a design in progress. Another design in progress feature is how to clean up PVCs used by a stateful set when the stateful set is being deleted or scaled down. If you are interested in getting involved with SIG Storage, take a look of the SIG Storage Community page. It has a lot of information to get you started. We have bi-weekly meetings that happens on Thursdays at 9 a.m. Pacific time. It is a Zoom meeting. There's an agenda doc on that SIG Storage page. You can feel free to add items to the agenda doc for discussion. We have a lot of bugs that we need help with, so help fix a bug and help write tests. Help write features. Kubernetes releases usually every quarter, but this year due to COVID-19, there are only 3 releases. For every release, we will be doing planning. So in the beginning of the release, you can come and join our meeting and participate in the planning, and you can see if there are any features you are interested in helping out, and you can get assigned to work on that. Every feature must have an enhancement issue and a cap, which is a design spec. We definitely need more contributors. So this is the end of this session. We have some additional resources at the end of this slide deck. You can download this to take a look. We hope you find this session helpful. If you have any questions, please don't hesitate to reach out to us. Thank you.